Hi everyone, this is Fahad Mirza and I welcome you to the channel. In this video, I'm going to show you yet another depth estimation model which is called as Distill-Any-Depth. I have been covering these depth estimation models a lot on the channel in the last couple of years, and I have found out that this area of AI has improved a lot. If you start from this Apple's Depth Pro and then just keep going down towards Marigold or Depth Crafter, Eco Depth, Lotus, and the list goes on and on and on, you would see that we have come a long way. And I'm so happy to be part of this journey. And that is why when I looked at this project, Distill Any Depth, it seems quite promising. So we are going to install it locally and then we will test it out how it works. If you don't know what exactly this depth estimation is, so this monocular depth estimation or MDE aims to predict scene depth from a single red, green, blue image and really plays a crucial role in 3D scene understanding. There have been a lot of advancement in this field, as I mentioned earlier, where Zero Shot MDE leverages normalized depth representations and distillations based learning to improve generalization across diverse scenes. But the current methods have few of the limitations, like they rely on global normalization and they can also amplify noisy pseudo labels. That is where this new project helps out. So what they have been doing, if you look at this methodology, they have been systematically analyzing the impact of different depth normalization strategies on pseudo label distillation, and this is where this cross context distillation shines, that integrates global and local depth cues to enhance pseudo label quality. This is also introducing a multi-teacher distillation framework that exploits complementary strengths of different depth estimation models, or in simple words, they have taken a lot of goodies from the previous project. Some of them I already shown you, and then they have created this new distill any depth model. So let's try to get it installed and then we will see how it works. Let me also give a huge shout out to Mast Compute who are sponsoring this video. If you're looking to rent a GPU on very affordable prices, I will drop the link to their website in video's description. Plus, I'm also going to give you a coupon code of 50% discount on a range of GPUs. Also, another sponsors of this video are AgentBot. AgentBot lets you effortlessly deploy a personalized knowledge bot across platforms like Discord, Slack, and others. It is ideal for open source tech communities and startups that provide user support, and I will drop the link to their website in video's description. Let's now try to get it installed. This is my Ubuntu system, by the way, and this is my GPU card, NVIDIA RTX 6000 with 48 GB of VRAM. Now, these depth estimation models are not huge, and you will see shortly as I'm creating this Conda environment with 3.10 because it works and really optimized for this version of Python. So let's wait for this to get created. And now let me git clone this repo, and that should be done fairly quickly. And then we need to install all the requirements from the root of the repo. This is going to take a bit of a time, so let's wait. And while that happens, let's also quickly have a look at this methodology a bit more, as I was mentioning about it earlier. So you see, this is a distillation framework that has been designed to leverage unlabeled images for training zero-shot monocular depth estimation models. So this is where they are combining local and global depth information to enhance the student model's prediction. So in this particular scene, there are two scenarios. The top one is shared context distillation, where both models use the same image for distillation, and second one is the local global distillation, where the teacher predicts depth for overlapping patches while the student predicts the full image. Okay, so let's go back. And it took fair bit of time, but it is done. Next up, we need to go to the detectron directory in the same repo, and then from there we need to install all the requirements in the editable format. Let me quickly paste the command here, and this is the command which we need to run. This shouldn't take too long. And then we just need to go back, sorry, not this, we just need to go back one directory and then install the rest of the prerequisites from the root of that repo. And that is all done. So this is all the installation which we needed. Let me clear the screen. And now from here, in order to launch the demo, which is primarily a Gradio demo on our local host, all you need to do is to run this. And there you go, it is running on our local host at port 7860. Let me open it here. There you go. So our depth estimation demo is running and it is fully loaded. Let me quickly show you the VRAM consumption. You can run it on CPU. It's a very lightweight. You see, it is not even using my VRAM at all. So it is running on CPU. Let me get an image from my local system. And sorry, I was totally wrong. First time when you run it, it downloads the model. I thought it downloads it as part of that script, so my apologies. But you see, the model size is just 1.34 gig. And now the model is loaded, and when I selected this image, it has generated this. So let me show you the VRAM consumption again. Let's check it out. Okay, so it is consuming just a touch over 3 gig, which is not bad. As I said, you can run this model on your CPU too. It also comes in a smaller size too, which is even less than half this. So if you're struggling, you can use that one, but I think this one is okay enough. So and look at this. This is really good depth estimation. As you can see, maybe we will check out with few other examples. Let me select another image. So there was this gaze image which I just wanted to test, because you see that normally in the speed cameras and stuff, mobile detection one, this comes very handy. I will just let it run. So it takes around 10 to 20 seconds. There you go. How good is that? This has improved a lot, this area, really, I can tell you. Okay, so this is cool. And I'm going to just test it out on a blurry image. Let's see if it can do the blurry images. Should be fun to see. There you go, perfect. So you see, it has really got that in RGB. Okay, let's try one more. So I'm not sure how to find any fault in it, because this looks so good at the moment. I think I have run out of images. So let's try out one more, which is slightly harder, I would say. So this is a magnificent Madurai temple, Meenakshi temple in Madurai. So let's try it out. There you go. So what do you think? I mean, I was also hoping maybe this structure, the outward one, should be shown here. There is, but I think should be better, but not bad at all. Okay, let's try out one last one and then we will call it a day. Maybe I'll just give it this rush hour or traffic jam. This is another thing which is very common use case of these depth estimation ones. There you go. Pretty good, I would say. So look, I believe really good model, very good quality one, and things have come a long way. But keen to hear your thoughts on them. Try it out. If you like the content, please consider subscribing to the channel. If you're already subscribed, please share it among your network, as it helps a lot. Thank you for watching.